All right, good afternoon. Let's try it again. Good afternoon.
Good afternoon.
All right, thank you so much. Well, welcome to reInvent. My name is Arun Gupta. I'm a principal open source technologist at Amazon. And with me today I have Raffaele.
Raffaele, software engineer at Zalando.
All right, let's talk about it. So today we're going to be talking about mastering Kubernetes on AWS. So as I said, I am a principal open source technologist at Amazon. I'm part of the open source team. I'm also the board rep for AWS on Cloud Native Computing Foundation. I'm responsible for the strategy for CNCF within AWS.
I'm Raffaele, as I said, software engineer at Zalando, mostly working on containers and container orchestration. I love Go. I hope you do. Yeah, I'm Italian, so I love wine and running.
All right, well, I'm a runner too. So today, this is not intended to be a Kubernetes 101 session. What we are doing is we're talking about 4 different aspects of Kubernetes, essentially, and then talking about how you could be successful, really master those topics in context of Kubernetes on AWS. So the topics that we're talking about is how do you set up a cluster on AWS? We'll talk about how do you do CI/CD of your applications? What are the offerings, opinions, practices around that? Then we'll talk about identity and access management. How do you make sure that your IAM investment into AWS can be repurposed in context of Kubernetes? And then last but not the least, how do you get visibility in the cluster? And on what does really visibility mean? And the way we are intending to do is, I'll talk about it, what is it that we are seeing among our customers, the practices, and then Raffaele will go about, practices are good, but here is an opinion on how we are running it in production today. Right? So let's get started on that. So let's talk about Kubernetes cluster setup choices. What are my choices today? Well, if you look at it, in terms of Kubernetes cluster itself, what do you mean? You need to install a cluster, upgrade a cluster, delete a cluster, deploy applications over there. Lots of ways by which you can do that today. In terms of development, of course, you're looking at Minikube. So Minikube is literally a CLI that you download on your machine. It leverages hypervisor framework or VirtualBox, whatever is there on your book, and then it creates a VM. So it's a single cluster, single node cluster of Kubernetes that is on your machine. Very easy for me to operate in a flight mode, for example, because I don't have to really worry about it, provided I have all the right images downloaded. If you're looking for an option from the community side of it, cool. Minikube is good, but a single node. I want to create a multi-master, multi-worker cluster on Amazon. Kops is a beautiful option. I love it. But there are 18 different ways by which you can run Kubernetes on AWS. And so we maintain a list on this domain, kubernetes-aws.io. We talk about different options over there. One of our favorites is Kops, and we'll talk about that a little bit later as well. Now, of course, if you are doing production, this is a brand new release that Andy Jassy talked about in his keynote this morning. If you're looking to do it in a highly available, secure, reliable manner that Amazon is used to, then we have Elastic Container Service for Kubernetes. We'll talk about a little bit of details about it. Now, if you want to learn more about it, then Pinion 7 is where my colleague Brandon is talking about this service right now. Well, I wanted to be in that session myself. Anyway, there are other options as well, CoreOS, Red Hat OpenShift. The star really indicates is Red Hat has built a lot of tooling in an opinionated way on top of Kubernetes platform over there. And then, of course, there is CloudFormation, Terraform, whole different ways by which you can create a Kubernetes cluster. It really depends upon what your need is, but there's a wide variety of choices on how can you set up a Kubernetes cluster on AWS. Now, let's talk about it. Well, of course, we have partners as well. So Docker, Mesosphere, Heptio, these are our very good partners. Docker particularly has talked about how they're going to have Kubernetes support baked into the Docker desktop itself. Now, let's talk about Kops a little bit. Well, what is Kops? Kops is essentially a tool that is created by SIG AWS. There are 2 lead authors of it. Those are Chris Love and Justin Santa Barbara. We work with them very closely. These are the guys who essentially created the tool Kops, and Chris Nova was involved as well. Now, SIG AWS is where this is being discussed. There is a Slack channel for it, and there is a office hours that happens every other Friday. So it's truly community supported. There is no really company behind it. There is no production support that if you run it on your own, there are all the tools available in terms of upgrading and all those things, but you're on your own or rely upon office hours. It can also generate your CloudFormation or Terraform scripts, so that could be a good starting point from you, and then you start with those scripts and then create your cluster from there on. Of course, the project is living on github.com/kubernetes/kops. And here is a command which kind of gets you created with kops. Essentially, what you can do is you can specify how many masters I want, what is my master instance type, how many workers I want, what are my worker instance types, what kind of networking do I want? Do I want to rely upon KubeNet, or I want Calico, or I want Weave, or I want some other networking over there? And then, of course, you can start specifying, if you want a HA cluster, what are your availability zones? So by simply giving these steps, kops automatically create a cluster for you across multiple availability zones in a region. Let's talk a little bit about Elastic Container Service for Kubernetes. A brand new service, literally give me goosebumps to talk about it. This is the first time I'm talking about it publicly, so this is very exciting for me personally. Essentially, what it gives you is a managed Kubernetes control plane. Setting up a Kubernetes cluster is hard. It's not for the faint of the heart. Managing etcd is not for the faint of the heart. Running up a cluster, what size is going to be, what the instance type is going to be, what if my master fail? It's not easy. So that's exactly what, that's the hard problem, and that's what we like to solve. That's what essentially EKS gives you, or Elastic Container Service for Kubernetes. The worker nodes you bring, very much like in an ECS fashion. So you bring your worker nodes, and you say, here are my worker nodes, now connect them to my master. And in terms of master, essentially, we are giving you a highly available master, etcd nodes. You give a URI. From your perspective, we take care of updating, patching, scaling, maintaining those masters. And then you bring your worker nodes and connect to the master, and you're good to go. What are some of the core tenets of EKS particularly? Well, just like in a very classical Amazon way, we want to make sure we give you reliability, visibility, scalability, high availability, all those abilities that we are used to from Amazon. We want to give you those capabilities as part of EKS. Most important for us is provide 100% upstream experience. There is no forking of Kubernetes that's going to happen here. What we are looking for is you are downloading Kubernetes, you are setting up Kubernetes cluster, you're running on Minikube, essentially setting up a context. We want you to be able to say, use Minikube context or EKS context and just deploy my application over there. So we want to make sure that anything that we do on the Kubernetes side of it, because control plane is of course ours, but anything on the developer experience, we want to make sure that is done in a very open source way. You're not required or forced to use any of the existing AWS services, but we will take care of the undifferentiated heavy lifting for you. So for example, if you want to run ALB Ingress Controller, we will give you a provision for that. You want to run Calico as a networking policy, so we're going to give you a provision for that. So anything on those lines, we'll take care of it. Integration with CloudWatch, CloudTrails, all of those will be offered to you. And last but not the least, which is again I'm very excited about, is we will be very actively contributing to the upstream project going forward. And there are several partners that we are working with, particularly Heptio Labs, once again, is a very good partner, and I'll talk about them a little bit later as well. So how does my API look like today? Well, of course, you can create your EKS cluster either using AWS console or using CLI. So in this case, for example, all I'm saying is AWS EKS, create my cluster, give me a cluster name. What is my master version? By default, when we go GA, first half of 2018, whatever the latest upstream version is that's going to be supported, and we're going to support previous 2 versions as well. And then I give it a role ARN. My role ARN is actually my IAM name, so which is the right integration that we are building into kubectl itself. And this is something we're working with Heptio Labs on. So that's about sort of my EKS architecture. But typically, if you think about it, when you create your Kubernetes architecture, you're looking at master, etcd, and worker nodes. This is all spread up. On the top and on the bottom, everything is your responsibility. We simplify that. We give you an API server. We give you a URI that is a highly available URI for you. You bring your worker nodes, you spread them across different availability zones, and you connect that to the API server and ready to roll. And the most beautiful part, as I said earlier, is where you take your existing kubectl and you deploy using that exactly with the experience that you are used to. So there is no forking. Again, I want to highlight that. It's all done out in the open source.
Thank you, Arun. All right, so as I said, this will be the opinionated part of the talk, where I'm going to show you how we've been doing Kubernetes on AWS at Zalando since more than a year now, in production, of course. But before going into the cluster setup, let's talk a little bit what is Zalando. Zalando is the leading European fashion platform. So if you're not from Europe, from the US, or from all over the world, you probably never heard of this. But to let you understand the scale, those are numbers. So we operate in 15 markets in Europe with 6 fulfillment centers, 22 million active customers, and some other numbers like 3.6 billion net sales last year. And most importantly, we have 14,000 employees, which of them, like 1,100, are actually engineers, work in tech, and they have experience in some years using AWS. Originally, we were using an on-premise setup, so we have our own bare metal data centers. We have some clearly some limited capacity to grow, to scale our applications. And this was a problem while our organization was growing. We went through a pretty major growth in the last years, and we're still growing pretty fast, so we needed more capacity. Moreover, all our deployment strategy was based on some custom tooling that we developed internally, which also meant that people need to learn those tools to use. We then we started a migration to AWS in early 2015, and the approach we took is essentially to go with a single Docker container running on an EC2 instance. This meant that the developer needed to understand what an EC2 instance is, which is actually not so hard, but they had to pick the right EC2 instance for the type of workload, which is clearly complicated for those developers. Our setup was heavily based on CloudFormation, which we used to deploy. We then decided to simplify this to achieve higher density, introducing Kubernetes on AWS, which we found like a very great tool because of, first of all, its API and being open source. So our setup is based on multiple AWS accounts, and we have essentially, we provision one single Kubernetes cluster per AWS account. And we currently run 50 Kubernetes clusters, so quite a huge number. Those clusters are relatively small in the sense that, and we took this decision because we wanted to, first of all, limit the impact of possible problems or outages only to the single cluster that would be affected. This makes sure that not the entire company can be affected by possible cluster outages, which clearly is helpful when you get started with such a tool. Another important point is that the Kubernetes source code, when we started more than a year ago, as I said, used to be not really optimized to deal with AWS rate limiting. And this was particularly true when mounting ABS volumes. Our setup is based on CloudFormation. The decision was actually pretty easy for us because, as I said, we were using CloudFormation since quite some time, so we had existing experience in tooling to deal with CloudFormation, so for us was just first-class citizen. As a base setup, we use Container Linux as operating system. We use the standard AMI that you find on AWS. We don't do any AMI customization, which frees us from some operational efforts. Another decision that we took is to use Flannel as overlay network, and we decided to do that to support clusters that are bigger than 50 nodes. And this was due to the limit to the entry in the routing table in AWS. And as I said, we have small clusters, but we wanted to keep this option open to have a bigger cluster, which sometimes we actually used. The approach that we embrace is the one of the immutable infrastructure. We don't do updates and reboots of nodes. Instead, whenever we have a configuration change, which is actually quite often, we do a replacement on nodes one by one in a rolling fashion. So our cluster setup looks like that. So we have a master autoscaling group for the master nodes that is spanning 3 availability zones, and another autoscaling group for the workers, which is also spanning 3 availability zones. So this is a fully HA setup. Those availability zones are in the European region, so Frankfurt. We deploy etcd outside of the Kubernetes cluster with CloudFormation as well, with a 5-node cluster. The master, as I said, is fully HA. So in front of them, you'll find a classic load balancer that is used both for the interaction for the user, for example, via kubectl, and for the communication from the worker to the masters. As I said, operations, this is very important for us. So we have 50 clusters. So if there are any ops here, you know that you probably don't want to do manual upgrades of those clusters. First of all, because this is very, very error prone. You could break anything. at any time, and because it's time consuming. So we developed two components. The idea here is very simple, and I want to explain to you. One component is this cluster registry. This is just a metadata service, just expose a REST API, and it stores this data in an RDS database, and this contains information regarding each of those clusters. So what is the life cycle? Are they requested? Where are they created? And all these kind of things. And it points as a reference to a Git repo, which is actually on git.com, and you can find it on our organization, which is actually contains all the configuration for this cluster. So this we made available open source such that people can watch it and provide us feedback or learn from what we learned after more than a year in production. And then we have this component, Cluster Lifecycle Manager. And this is a very simple Go code that actually watches this configuration, so this metadata regarding clusters, and it watches this Git repo, and whenever there is a change, it will just make sure that this change is applied to the cluster, such that, and this actually means that there will be a CloudFormation stack to update. As I said, we use CloudFormation, and then there will be some additional components that are completing our setup, for example, kube2im that we'll show later, that actually are applied as Kubernetes manifest. All right, this was it. So let's talk about CI/CD.
All right, very cool. So those are the way, some of the choices, the way we have looked at it, how you create your Kubernetes cluster. Let's talk about what does it take to build a deployment pipeline. Essentially, we're talking about git push to prod, essentially, of my applications. Now, Jenkins, that's sort of one of the biggest solutions that developers and customers are using today to create CI/CD pipeline. So we'll talk about, how do we see, our customer base using Jenkins for doing deployment pipelines with Jenkins. At AWS, we have, of course, the CodeStar suite. We have code pipeline, code commit, code build, and I'll show you an example and a reference architecture that we are building on how you can use that set of tools to deploy your application from in development to production. And then, of course, AWS relies upon its partners pretty heavily, so we have a lot of partners, even in this space, for example, GitLab, Shippable, CircleCI, or CodeShip, who we work with, who offer tools on how can they deploy their application to production on AWS. Essentially, their bottom line is Kubernetes, wherever the Kubernetes is running, it doesn't matter, but it works on AWS too. So when you start with Jenkins, essentially what you have is a Jenkins file. In the Jenkins file, what you could do is you can very easily set up a pipeline. And in the Jenkins file, essentially what you're specifying is a YAML syntax over here, and all I'm doing is I'm defining different stages here, okay? So let me walk you through those stages. So the first stage essentially is a checkout stage, that every time I do a git push, well, of course, you have configured your GitHub hook and all those things, but every time I do a git push, what is it gonna do? Well, it's gonna check out my workspace. Once it checks out my workspace, then I'm saying, okay, in that workspace, I have a Docker file. Using that Docker file, essentially, build my image. So that's my second stage. I build my image. Then my third stage is, okay, I build the image now. Now push that image to whatever your favorite hub is. Docker Hub, ECR, whatever your registry is, wherever your registry is configured. In this case, we're actually pushing to Amazon EC2 container registry. And then, of course, last but not the least stage is, of course, to roll out your application. And for that, essentially what you're using is a deployment.yaml, and you're using a very native Kubernetes concept over there to roll out your application. Okay, so essentially what we're saying is Kubernetes describes the deployment, you're just setting the image name, everything about the image, the deployment stays the same, the number of replicas, you just rely upon native Kubernetes constructs over there. And once you have that update application up and working, then essentially your pipeline looks like this on a Jenkins dashboard. So you can literally see from red to green and how the stages are progressing. And this is something that we will be adding to the Kubernetes on AWS workshop, which I'll talk about a little bit later as well. Now that's one way we see our customers using it. The way that we recommend to our customers also is, of course, using AWS CodeStar suite. And essentially the way it works out is, a developer, they push a code change to GitHub repo, to whatever, a Git repo, essentially. And with AWS CodeStar suite, you can configure GitHub to be one of the backend repos. Code pipeline, essentially, in that case, is looking for any changes to the Git repo. Once it happens, it says, okay, a code commit has happened. I got the change notification. Once you get the change notification, you automatically invoke code build. Code build is what's gonna build your Docker image. It's gonna push it to the Amazon Elastic Container Registry. That's sort of my step 3. And then it calls a Lambda function. And the Lambda function essentially is basically a Python function which uses Kubernetes Python SDK to trigger my deployment. It says, all right, I got the change here, and then I'm going to trigger the deployment to Kubernetes. So your kubectl, for example, the credentials for kubectl are stored using AWS parameter store, and the credentials are encrypted on rest using KMS. So very secure credentials. So you have triggered a deployment to Kubernetes, and then, of course, that pulls the image from your EC2 container registry. So that's, again, one of the reference architecture document that we are working on, and it will soon be added to the workshop that, again, I'll talk about it a little bit later.
All right, thank you, Arun. So when talking about CI/CD at Zalando, we have to talk a little bit of how we got into the topic of CI/CD with Kubernetes. So we started from a situation where we had already something like around 200 engineering teams. And in our previous AWS approach, those teams were entirely responsible for their CI/CD setup. This means they had some basic tool, and some internal teams, they provided Jenkins as a service internally, so to say. But the teams were responsible to choose the tool they wanted and to set it up to have their own pipelines for production deployments. This meant in the end we had several systems that were used to deploy to production, and we had this bigger topic of compliance, in which we have some compliance rule that, of course, as a publicly listed company, we have to respect. And the fact that those deployments have to follow those rules was entirely left to the teams. As you can understand, this meant that the teams could break those rules, and they would get a violation, and they would have to solve it. When introducing Kubernetes, we took a chance to actually fix this at the organizational level by making sure that deployment to production systems were only possible via CI/CD pipelines. This means, like, if you tried Kubernetes, if you know Kubernetes, I'm pretty sure you did, you probably know kubectl or kubectl, as you wish to call it. It's nice to interact with the cluster, but you don't want to use this probably on your production systems. We did that so to enforce CI/CD best practices and to exactly to have this idea of hands-off operation. So we don't want developers or teams to just continuously interact with production system, but just go through a consolidated CI/CD process. This also allows us to have this compliance by design idea in which all the compliance check that we need, for example, we have an internal Docker registry that we use to host our images, is the only one that has to be used. We can check that at the deployment time. So at the first iteration, we started with Jenkins. So that's the obvious one, and the one we were already using, and we were familiar with it. And the challenge that we had, or the team that were working actually on this topic had, was really to map Jenkins to our organizational requirements. One of them, for example, this is not a complete list, but one of them is traceability. So given a production deployment, what was the code commit that originated this deployment? And security, how to build like really secure images with isolated VMs or containers and so on and so forth. So the decision that we took is to really have one Jenkins per Kubernetes cluster. As I said, we had like 50 of them, and we went to this approach, which looks like kind of radical, but it was actually the simplest thing to go with a really multi-tenancy. So to really have the people that have to access this cluster only access this cluster. It was very easy to get started, but it didn't really work. It didn't really work for a number of reasons. One of them that we found out Jenkins was, or at least the way we set up Jenkins was not entirely cloud native. We had issues like upgrading, keeping upgrading, plugins, and credential distribution. For example, how do we properly distribute those credentials to push to our internal Docker registry, and so on. Moreover, we set it up using a single replica stateful set. Which meant that whenever we do this thing that I told you, like rolling updates of nodes, this meant downtime of this Jenkins instance, which, as a learning, right? There is no, in this cloud native world, there is no such thing as a single replica deployment or stateful set. So as a second iteration, we started trying a bunch of those tools. We tried GoCD, Spinnaker, and this was more than a year ago again. And this tool was just not ready for us. So what we did is essentially we started building our own solution for building and deploying it. And this allowed us now to have a much faster build time compared to our previous setup in which we have this master-slave approach with Jenkins. And we built the idea of deployment to Kubernetes out of the box with it. So what I really want to tell you, apart from the tool here, is really the idea of how our deployment model looks like. So engineers really we exposed the entire API of Kubernetes, right? So they will use directly those Kubernetes YAML, so deployment YAML, ingress, services, whatever they need to use. And we have a Git repository in which they put this YAML. So this Git repository could be the same repository where the code lives, or it could be an entirely different repository, but this doesn't really matter. There is a deliver YAML, which is just a configuration file that contains like steps, for example, deploy to staging first and to production later, just to make sure everything works, of course. And the important part here is that every single thing we deploy is versioned in a Git repo, it's backed up, it's logged, and it's approved by 2 engineers. So those things can be deployed only when they're merged to master, and to merge to master you need the approval of another engineers. And this allows us to solve these problems of, for example, compliance. All right, I am.
All right, let's talk about it. So now, we've talked about 2 aspects so far. One is sort of setup, how do you set up the cluster itself? Then we talked about how do you set up a CI/CD on it. The third aspect that we want to talk about is IAM integration. Now, what is identity and access management? It's a single entry point by which you can control access to your resources, what can be done, who can do it, and things like that, for in your AWS environment. Now, it really enables a secure access. That's how you log in to your AWS account, to your CLI, to your console, all of that, okay? Now, when you create a Kubernetes cluster using kops, for example, today it has 2 set of roles. One is an IAM role that is for the master nodes, and another IAM role that is for the worker nodes. And you can see the permissions that are granted to them are a little bit different because master needs a little bit more capability. Because, for example, when you are creating a cluster using kops, your state is stored in the S3 bucket. So the master needs the ability to write to the S3 bucket. But the worker, for example, would need only to read that from the bucket. So the permissions are a bit different in terms of master and worker, okay? Now, that's the IAM role over there, but what we need, we need a first-class integration for IAM in Kubernetes itself. And what that means is, when I'm doing kubectl, do I have the ability to use IAM there? I don't today. When I'm running my pod, can the pod assume an identity? There are solutions around it, but they have like pros and cons. So let's talk about them a little bit. As I said, Heptio Labs is one of our very good partners. We have been working with them. They have this project called as Authenticator. Essentially, Authenticator, what gives you is the ability to do authentication using IAM, using kubectl. So let's take a look at this, how this project works. So think about this, you have kubectl, which is your CLI. You have the Kubernetes cluster in the middle, and then, which is sitting on AWS, of course. And then you have your auth service, AWS auth service, which is sitting in AWS environment. So now, from your kubectl, essentially, what you're doing is, I want to be able to pass an identity. Typically what happens is, if your kops cluster is sitting on the runtime, let's say if you have assigned a runtime identity or IAM to a pod, but when kubectl is talking, it's using a different set of credentials. So those two are disconnected. So this effort is essentially to ensure that I can pass my IAM credentials from kubectl itself using a CLI option. And remember when we were creating the AWS EKS create cluster, we were specifying a role ARN. That's what this IAM identity is. So essentially from kubectl itself, I can pass my AWS identity. The kubectl cluster or the Kubernetes cluster sitting on AWS will talk to my AWS auth service using that IAM role. It'll tell me, authentication, authorization, what kind of policies are attached to that role. It'll figure out what needs to be done. Then within Kubernetes itself, you can set up RBAC. That, okay, I got what IAM role is capable of, then attach that IAM role using RBAC in Kubernetes itself. What can you do in Kubernetes? So you have passed the IAM role, it goes to the cluster, it goes to the auth service, comes back to Kubernetes cluster, then does the RBAC authorization. So authentication happens with the AWS auth service. Authorization happens using RBAC. And then accordingly, your action is allowed or not allowed. So it's a really nice combination. Essentially, this is going to be a plugin to kubectl, where and how, and it's done in open source, but where and how it gets integrated upstream is the discussion that we are having today. Now, we looked at IAM role for kubectl. Let's talk a little bit about IAM role at runtime. Now, as I said, there's IAM role for master and IAM role for worker, okay? But that's one IAM role for all my worker nodes. What I want is the ability where each pod could assume an IAM role. Essentially, that's a capability and a feature that I want. And the way it works today is, if you spin up a pod, the pod really talks to the EC2 metadata service, figuring out, okay, this is what I'm requested to do. Can I do this? And it does it accordingly, all right? Now, let's take a look at it. What are the possible solutions for that? So a plugin that we have seen extremely popular within our customers and developers also is kube2iam, for example. Well, let's see how this works. Now, of course, you have your worker nodes. You got 2 pods and a pod, and then you have your EC2 metadata API. So what happens is the kube2iam is a plugin that gets installed as a daemon set. Once you have that daemon set, essentially, now your pod, and in addition, you also have a secure token service, essentially, okay, that's sitting in the AWS environment. So the secure token service is a web service that enables you to request temporarily time-limited privilege credentials, and then that can be used for your pod, essentially. So now, when you make a request from pod, instead of going directly to the EC2 metadata API, it gets intercepted by the daemon set. The daemon set now then talks to my secure token service. It retrieves those temporary credentials. It gives those credentials, and using those credentials, actually, then it talks to my EC2 metadata service. And then, accordingly, the permissions, because depending upon the roles and the policies that are attached, the pod can do the thing or not do the service. Okay, so that's sort of the whole idea about kube2iam. Now, that's sort of how the backend works for kube2iam. But what does it mean, really? How does my app definition change? Because end of the day, when I'm building my application, I need to somehow still specify, oh, this is the pod role, or this is the IAM role that the pod should take. So what happens is, essentially, in my deployment, what I'm showing you here is the deployment. In the deployment, I am saying, and I'm adding an annotation. And in this annotation, all I'm saying is, here is my IAM role. So my app-role is essentially an IAM role that has been created. So you give a full ARN for the role over here, and you attach that to the pod itself. Now, there are issues around this, because essentially, if you're running kube2iam, because when your pod is running in a particular IAM, your worker node should have the assume role capability. The worker node should be able to assume any role, essentially. And that's a potential hazard. So we have seen kube2iam working, but again, that's not something that we recommend from our sides. What are my other options if I want to do an IAM role for a pod at runtime? So HashiCorp Vault. Well, HashiCorp Vault is a tool for managing secrets. It secures, stores your tightly controlled access to tokens, generates temporary IAM credentials for you, and all those things. So now, essentially, what you could do is you could set up a HashiCorp Vault either on EC2 or wherever your Vault server is running. So what happens is now, when you make a request, in your app itself, and again, there are design patterns for this in our workshop that I'll talk about a little bit later, is you can set it up as a sidecar container. So let's say you have an application that needs a temporary credentials. You set up a sidecar container. That sidecar container goes and talks to the Vault server, generates your temporary IAM credentials. Those are the IAM credentials, then you can be utilized by your container in the pod. Again, these are sidecar containers, and then that's the IAM credential used by the container to do the real execution. And based upon the roles and the policies attached to the pod, you are allowed to do the task or not allowed to do the task. Something, again, that we are super excited about is, again, this is something out in the future, is SPIFFE, so our Secure Production Identity Framework for everyone. Now, this is a framework that is under active development and in the very, very early stages of development itself, as I think it's about 0.2 version. But let me tell you what SPIFFE gives you. Well, 3 things. From a cloud provider perspective, it gives you a standard for pod and container identity, because it eases the burden of passing secrets, like IAM credentials. I don't have to worry about how this is going to be done across clouds. So we are very excited in that sense. Even though SPIFFE is looking for to be cloud agnostic, but from a cloud vendor perspective, we like that aspect. And we are working with, again, this is something that Heptio Labs is very actively involved with. So we are excited about it. SPIFFE, as a matter of fact, has been proposed as a CNCF project, or Cloud Native Computing Foundation. And we are in the favor of that project because essentially, we are excited for the potential of SPIFFE. Because it could work on not just any container runtime, whether it's Docker, whether it's CRI, whether it's CRI Containerd, you pick your favorite runtime, it'll work for that. And then last but not the least, it can enhance the capability across different projects. So think about Istio and other service meshes who don't have to worry about how the credentials are going to be passed across different services, where out in the future, SPIFFE could become the mechanism by which you are actually passing credentials across these different services.
Thank you, Arun. All right, so when talking about IAM at Zalando, we have to actually talk about two IAM systems. So the first is the AWS IAM, and the second is an internal IAM systems that we use that I will call for the rest of this presentation Platform IAM. I'll get a little bit more into that. So for AWS IAM, we use Kube2 IAM in a very similar setup to what Arun already showed. So we deploy a daemon set, which means we have one pod per every node that we use, and we use it for doing this assignment of IAM roles to pods, to workloads. So this we use with this annotation as showed. But what I wanted here to tell you is why this is working with us. So it's not really, so the how was already shown. I want to tell you why this makes sense. And to do that, I want you to remember this previous slide that I showed you, in which I told you that every single modification of those deployments has to be versioned in a Git repo and has to be approved by someone. And the trick here is really that we log everything, and we trust two engineers to actually decide which role works for them. And this is the whole idea of 4 eyes principle. So there is always 4 eyes behind the deployment. And in this way, we trust them to actually take this, the right IAM role. That's the second IAM system. So we currently run a microservice infrastructure. So we have hundreds of those servers, if not thousands, I have no idea anymore. And those services are talking to each other, providing OAuth tokens. So every one of those servers is actually protected via OAuth. This means that we have some tokens for services, for service to service, for communication, and for employees as well. So one question, so the system was already in place, has nothing really to do with Kubernetes, but of course we had to integrate this. For example, employees get tokens that they can use to talk with these APIs. So how do we make sure that we can use exactly the same existing infrastructure to talk with the API server of Kubernetes? And kubectl is a native integration for that. You just need to have those tokens. And whenever you talk with the API server, even using kubectl, you provide this token in the request, you can enable some way of verifying those tokens. What we use is this flag for the API server, which is the webhook. This means every time you make a request against the API server will forward this, an additional request to a webhook. This is really an application that you can write, which has a REST API, will get a specific type of request. And this webhook will verify this token and will say, okay, authentication done, right? You're authenticated. Then there is another flag for webhooks, also for authorization, and we use this as well, where we can really realize, is this user authorized to actually get access to this cluster or not? So this is a very powerful native Kubernetes extension point that is very helpful in case you try to get Kubernetes running inside your organization and you want to integrate with an existing IAM system. Then what I have here is that we are slowly transitioning to RBAC, which is actually much more flexible in terms of how you can customize the roles for the cluster. And the slowly here is really because those webhook systems really work well for us and is serving well since more than a year now. So I talk about those microservices, right? I say they have to talk with each other, providing those tokens. And we really want to make the transition to Kubernetes from the existing AWS setup really, really easy for developers. So we don't want them to, of course, go through a lot of efforts to actually change the way their application works to only get tokens. This should actually work out of the box. They already have that. And what we did is actually create a small service, which we call Credential Provider, and a custom resource definition. So if you're familiar with a custom resource definition, this is really like, we really give it to our users to just say, okay, I want to have a token for my application, and the token should have some particular scopes, right? Whenever they submit that to the API server, there is a small service, the Credential Provider, that reads this custom resource definition, talks to the internal IAM infrastructure, and it then writes back to the API server a Kubernetes secret. So this means application can just mount secret like you probably always did in Kubernetes. So this means that this whole IAM infrastructure is integrated in a very native and declarative way into Kubernetes. Visibility, that's a great topic.
All right, let's take a look at it. So, I mean, cluster is all good and done. I mean, everything is happy, when things are looking good. But when things are not looking good, you need a little bit more visibility in your cluster. So let's talk about different aspects of visibility. So the way we look at it is, in a cluster, well, I mean, first of all, look at the cluster itself. You have a cluster. Cluster consists of multiple nodes. On those nodes, you have containers running, whether running as pod or deployment or replica set, lots of containers running. And then you have application. So there is visibility at each of the level. End of the day, if anything goes wrong in your application, you want to have the ability to dig in from your application to container to cluster to actual node and figuring out what's really happening. So that's one aspect. And then on the top, what we're looking at is, what are my different ways of visibility, essentially? So I could have logs, like application logs, or my systemd logs, or my container logs, or my Docker logs. I could have metrics, my health metrics, how my container is doing, how my CPU is being utilized. I could have events, node going down, node coming up, replica set scaling up and down. I want to have those events. I want to have alerts. I would rather somebody do the task for me if something is happening. So for example, horizontal pod auto-scaling. So if my cluster needs to scale based upon HPA, or if a cluster needs to scale based upon my CloudWatch alerts, I want that action to happen. And then last but not the least is, across my microservices, if I want some tracing to be done, how does that happen? My containers could be written in multiple languages. They could be hosted on multiple nodes. So how do I get application tracing? So the point being, you have 5 different aspects of visibility and 4 different sources of visibility. All of them should really come from all of them to provide a little bit more holistic picture. So let's take a look at it, some of the options that we see our customers are using today. If you take a look at logs, the first and the most obvious way by which you get the logs is using kubectl logs, and which essentially gets the logs from the container and gives you the logs back. Essentially, container writes it to the systemd, and then it picks it up from the systemd and spits out as using kubectl logs. It's a very convenient way for you to get the logs of what's happening. And that works for containers. You say kubectl logs, you provide the resource name, and it brings you the logs from that resource. Now, the other thing other stack, so to say, there are lots of ways people use it, but the other stack that we have seen our customers using is the F stack, which is essentially a combination of Elasticsearch, Fluentd, and Kibana. Okay, so let's take a look at it. What happens? Well, first of all, Elasticsearch is what is used for indexing your data, and your Fluentd is essentially where your data is stored, and Kibana is a visualizer. Now you can plug and play whatever works in your environment, but this is a stack that we have seen a bit common and popular. All right, so let's take a look at it. Now here I have my inner region across 2 availability zones. I have 2 masters across, set up in an auto-scaling group. And then on the right side, what I'm showing you is my 4 worker nodes, again, spread across 2 availability zones. So that's sort of my cluster setup here, okay? Now, if I were to run my F stack here, what I'll do is I will run a Fluentd daemon set over here, okay? That's running on each of the nodes, because essentially I want to get all that log back into my Elasticsearch, or my log store. Okay. Now, I could configure Fluentd to push all that log to my Amazon CloudWatch logs. And now Amazon CloudWatch logs can be automatically configured to push that data to Amazon Elasticsearch service. Now, Elasticsearch service. Now, you could go directly from Fluentd to Elasticsearch. Now, that's an option. But the fact that you have CloudWatch in between, and if you're building other alerts and events on top of it, it becomes very useful. And also, from CloudWatch, there is an automatic subscription where you can say, oh, you know what, automatically keep pumping data to Elasticsearch for me. And last but not the least, what you do is you build a Kibana dashboard on top of that. So that's sort of the stack that we are using, a lot of our customers using, and this essentially what gives them is the ability, a full visualizing aspect of how the logs are flowing across different aspects of your system. Let's take a look at metrics now. If I look at metrics, there is a node metrics. For node metrics, we have tools like Node Exporter that constantly spits out, the health of the node. How much memory, how much CPU, all those things, okay? Now, I need pod/container metrics as well. There are tools for that. So there is C-Advisor, for example, Container Advisor, which is an open source project, which kind of gives you metrics specific to the pod or a container. Or kubestate metrics, which is baked into Kubernetes itself. You need to enable it. Last but not the least, essentially, you're building your application. But when you're building your application, you could spit out your metrics on a /metrics endpoint. And we have example in the workshop, which basically is using a Prometheus client and spitting it out in a /metrics so that it can be scraped by a Prometheus endpoint. Or if you're building a Java application, then you can use JMX to start spitting out your JMX into /metrics. So you're really looking at the way on how your application is built and how you can expose the metrics from your application that is now consumable by standard tools that understands Kubernetes. All right? So you have your metrics coming from that. Then on top of that, essentially what you need is a cluster-wide aggregator. But that's exactly where Prometheus comes in. Prometheus can take all of these tools on the bottom row as a source and then give you a cluster-wide aggregation. Heapster is another way by which you can do cluster-wide aggregation. All right, that's good. Now, Prometheus is a time series database, but often we have seen Prometheus being back-ended by a data model, either InfluxDB or Graphite, because it provides a lot more way by which it provides a lot richer model in which the data can be stored. On top of that, you want to build some alerting capability because essentially all that data is good, but if somebody has to manually monitor it, watch it all the time, I'm spending a lot of human cycles in that. I want to build an alerting capability, and that's where we see Alert Manager and Capacitor, and people have built their custom solutions as well. Because CloudWatch is involved over there, on top of CloudWatch, you can build your custom solution. Okay, if this alert happens, automatically scale my cluster, or alert me and the way you want to do this. And last but not the least, essentially what you need is a visualizer over there. Now, Kubernetes by itself has a Kubernetes Dashboard that can be enabled as a plugin, or you can use Grafana, Kibana, whatever comes to your fancy, whatever works in your organization, use that as a visualizer tool. So this is essentially what we see as sort of the big picture of how metrics could be given. Now, there is no one solution fit all here. See what works for your organization, what tools are you comfortable with, what your customers are used to, and adapt that scenario. Let's talk a little bit about application tracing. Now, as we talked about, typically when you start using microservices, the thought of containers comes to you naturally. Now, it's not a requirement for microservices, but if you are going on a route or if you are using containers, then likely your applications are written in different languages and are packaged differently, but container is sort of your endpoint. Now, if your applications are distributed across multiple nodes, how do you know my container on node 1 is talking to container on node 3 is talking to container 4 on node 5? That's sort of application tracing is. So there are tools available from Amazon, AWS X-Ray in this case, which helps you to analyze and debug production distributed applications. And it particularly is targeted towards those microservices application. And what it does, it kind of helps you target the application. It generates a nice graph for you, kind of giving you an idea of what your potential bottlenecks are. And I'll show you a quick diagram on how the graph looks like. But essentially, you can trace end to end as the request is traveling through the application, looking at all the touch points where it might have gone and kind of showing you an overview of your application. So if like, this is one of the examples that is available. So what you could do is you can actually build a X-ray, even though it's a service, but you can build a Docker image. You can push that Docker image into your EC2 container registry or Elastic Container Registry, and then install X-ray as a daemon set on each of your node, the worker node, essentially, because that's where your containers are deployed. And then if you were to run a microservices application, in this case, well, we have a web application which is right in the middle. The client makes a request. It talks to a name service on the top and a greeter service on the bottom. And then it shows, OK, these are the 3 services that are essentially building my application. And it generates a chart. Now, I get the part it shows AWS :ECS. But that is just a visualizing aspect that's going to change when we have a better integration with Kubernetes itself. But this is a Kubernetes application.
Thank you, Arun. All right, so Arun mentioned already several aspects of visibility for clusters, right? And so I really want to tell you what actually works for us. So the way we are actually doing that. So of course you can, when talking about logging, do kubectl logs to get your logs, but what we really use for our application is really a centralized login solution. So we use Scalar. It's a centralized login solution where we ship all our logs to. So every of those Kubernetes cluster have as well an account on this platform, and we run then a daemon set, similar to what Arun said about FluentD. We run a daemon set that runs on every node, and this just ships the logs to this platform. So a user can just log in there and see all the information regarding the logs. This means, again, transitioning to Kubernetes is extremely easy for developers because they can just let their application log to standard output, standard error, and this already works out of the box. We're talking about monitoring. So here we really took the decision to keep what we already had. So we had Zmon, it's not Zmon, which is a monitoring and alerting solution which is actually open source. It's on github.com. You can go check it out. This is what we've been using since many years now. So we developed it internally. We've been using it. So we have plenty of people who are actually used to it. And the best thing you can do is not change those tools when everybody knows how to use it, right? You probably know this well. How we integrated Kubernetes with this tool is really by, for example, using Prometheus Node Exporter. So Arun already mentioned this. We deployed as a daemon set as well to get all those metrics regarding nodes into this platform. And in the same way, we use Hipster to collect spot metrics, which are also easily available in this platform. All right, so as I said, okay, this is really like how we do it or why we really kept this platform that we already had. But of course, till now we said like, okay, deployment or IAM, CI/CD, all these nice things. But really, we need to make life easy for our developers to actually monitor their application, because this is where all the fun starts when you put things in production, right? And what we did is essentially really developing some default checks and alerts for this platform for the deployed application that our engineers can just copy and reuse. In such a way, this is extremely easy for them to just get started with monitoring their application from the very first day they go in production. Additionally to that, we're using an Ingress Controller for all the traffic incoming into the cluster. And we have some default metrics in this Ingress Controller. For example, this is useful to monitor latency for services, error rate, and this we integrate really nicely in a tool that allows us to create service level reports to just make sure that everyone knows how a service is performing in case someone wants to build on top of the service. All right, so all of this is useless if you don't visualize it, right? So you need to have a way to see this information in a very easy way. And this is actually, in this slide, you can see a dashboard that we actually use to monitor our clusters. So this is really for operators. This is really for the job I do, which is really to see, for example, here you see in the top left corner, you see the latency for the API server. we monitor that because this is a very important metrics actually in Kubernetes where you see like how your API server is performing. If the API server is super slow, it means the whole story doesn't work anymore, the whole deployment story. This is very important. Other things we monitor is, for example, how many pods do we have running in the system. It's also important to see how our users are using and things like that. Number of deployments, mostly for statistics and other important metrics aggregated. Of course, this is only for ops. We have, of course, other dashboards for actually the people that are actually using the cluster to deploy their applications. So we have a default dashboard, for example, looks mostly like that. We have other ones. They can just copy it and reuse it. This shows you number of pods, memory usage, CPU usage, latency, P99, those kind of things. All right. So that was a great ride. So we talk about those 4 topics. But of course, this is not everything. There are more factors to consider. For example, there are many learnings after years in production that if you tried Kubernetes, you will also learn. But for example, you have to keep into account some things. For example, you definitely want to configure some sane defaults for your cluster. For this, I mean like limit range, which allows you to specify some default requests and limits in terms of memory and CPU for the application that don't specify them. Very useful. You could set you can set quota, for example, to limit the number of pods that can run in a single namespace, such that you don't have a single developer say, I want 10,000 of this. Might be too much for that particular cluster. And in general, you want to really know and understand the limits of your cluster. There are definitely some limits, like memory limits for the API server, for the controller. You're running on some EC2 instance. They don't have infinite memory. In this case, you're really managing the system, so you want to understand that. And last but not least, you really want to, if you're building such a system for developers or even for yourself, you really want to simplify the user experience. So Kubernetes is a great API. It's a great API to build on top of it, but if you have like teams that have to deploy with the system, they really want to have an easy experience. And you can do that by using Ingress, for example, for traffic, for incoming traffic. This is really a great abstractions, or tools like external DNS, which is actually an incubator, Kubernetes incubator project that we developed that gives nice DNS names out of the box automatically for your application. All right.
So if I take a couple of minutes now, this is where lots of our last few months have gone, essentially. We have built a brand new workshop. This is all done completely out in the open source. So what I'm going to do is I'm going to get out of the slide mode here, and I am going to be brave to open a browser here.
Kelsey Tower mode on.
GitHub.com, and I'm going to go to AWS-samples. Okay. And all I want here is, I want to show me the Kubernetes repo. This is the only Kubernetes repo in AWS samples today. So if you look at this here, this repo has lots of details about how do you deploy Kubernetes on AWS. Today I see about 396 stars. My personal goal is to get it to 1,000, hopefully by end of the conference, or at least by KubeCon next week. So with 500 of you in the room, I don't see a reason why that can happen. Well, first of all, this workshop is completely open source. The way we want to interact, Amazon, and at Amazon, we want to interact with you guys by filing issues. We would love to see you file issues that, Arun, tell us, how would you do this with Kubernetes on AWS? Or send us pull request. Every single typo matters. Every single typo that you can send a pull request for, every grammatical mistake, English is not my first language, every grammatical mistake that you can send a pull request for matters, because that much it improves the value of the repo. Well, let's get to the content part of it. In the content itself, if you think about it, we got sections, if your team is trying to get started with Kubernetes on AWS. I mean, some people talk about Kubernetes, it's a hard thing to learn, it's a hard way. I think that's just, making it extremely complex. I truly believe Kubernetes is a lot easier to learn if you focus on the technology as opposed to get mired down in the details of, what your cloud is really doing. So this workshop focuses exclusively on the technology aspect of it. So if you're trying to get started with Kubernetes, we say prerequisites, we use COPS today, and the due course of time, we will add EKS over here. That's pretty much the only chapter that we are looking at where we're going to talk about how do you install the cluster. But once the cluster is up and running, then we talk about Kubernetes developer concepts. So it talks about, if I can increase the font here. So we talk about what is a pod, what is a deployment, what is a service, what is a daemon set, how do you create it. We got code samples, and code samples to the extent where you can just copy paste that fragment, drop it into your repo, and say, I'm ready to roll with it. Now, that is only for beginners, essentially, but the way we look at it is, if you are looking at how do you do configuration management, where do I store my secrets? The things we talked about around HashiCorp. If you were excited by the dashboards, the Grafana dashboards that Raffaele showed, those dashboards you can create using this workshop. So if I go down here, for example, it talks about monitoring within a Kubernetes cluster. It talks about application auto-scaling. It talks about application tracing. We talked about AWS X-Ray. It exactly tells you how can you create your own daemon set for X-Ray, deploy it in your worker, and get rolling with it. You want to use core DNS for service discovery, so we allow you to do that. You want to set up an ALB Ingress Controller. I think that's where one of the contributions came from Raffaele's team as well. There are lots of ways by which you can do Ingress Controller. So all those mechanisms, and I like this to be no fluff, just stuff, essentially. So it's very, very hands-on driven. Pick any chapter here. So if you say managing IAM roles with Kubernetes, so it just talks about a little bit what the concept is. Then you can say, all right, I'm going to copy this file, and I'm going to drag this here, and I'm going to get started with this. So once again, we would love for you, would love to get feedback from you guys. File issues, send pull requests, a good friend, share this workshop with your colleagues actually as well. So thank you very much. I think we're pretty much out of time, but we're going to be hanging out in the hallway if you have any questions.